G'day everyone and welcome back to the Breeder Exchange podcast. I'm your host Sam Parrish and it's great to have our faces back on here for our live event. We're going to be joined today with a couple of really cool guests, and of course Jack Laurie, the man himself from Breeder Genetics, is going to be joining me to co-host. We've got a really cool lineup, like I said, of guests today, and we're going to be covering some pretty intense topics, but it's been a huge couple of weeks since we last caught up for our industry exchange with Scott and Hap. But Jack's been in New Zealand since then. I've kicked into the stud season. So it's definitely a very busy time for both of us, but we love getting on here and having a chat. So I'm going to throw it over to you, Jacko. Can you please introduce who we've got on the podcast today?
Sure. Thanks, Sam. Our first guest today is Peter McGilchrist, Associate Professor of Meat Scientist at the University of New England. Peter's research revolves around ensuring global customer satisfaction of the Australian red meat industry. Peter is the Vice Chair of the Meat Standards Australian Beef Scientific Pathways Committee, member of the Sheep Meat Scientific Pathways Committee, and President of the Australian ICMJ Association. Pete, thanks, mate. Thanks for being here. Welcome onto the podcast.
Yeah, thanks, Jack, for having us along today, mate.
And our second guest today is Sam Clark. Sam Clark is an Associate Professor of the Animal Genetics at University of New England. Sam has worked on all things genetics in species ranging from beef cattle to chickens on a ranging variety of topics from genetic selection and genetic evaluations through to genotype by environment interactions and optimizing breeding programs. He leads a range of research projects that look out for new and important traits, especially like feed efficiency and methane outputs. Sam, great to have you on. Thanks for being here on the podcast.
Thanks very much, Jack. Happy to be here.
So we just heard about your stories, Sam and Pete, and you're both coming out of that UNE program up at Armidale. Can you tell us more about UNE?
Yeah, so of course, thanks, Sam. So we have a long history with UNE, both Pete and I. After, of course, like we said, we've done undergrad, and then I did some postgrad study here as well. But what really is unique about UNE is it's kind of stuck with the same philosophy around agricultural research and rural research for the last 50 years or 60 years. So what UNE's foundation in agriculture was set around was that agriculture is part of a whole agricultural system that needs to be managed. And the whole system is made up of like soils, plants, and of course the animals that feed on those plants. And there's also those social aspects and economic aspects that we have to try and manage to have a sustainable ecosystem. So rural science at UNE is our flagship degree, and it was really set around those principles by a guy called Bill McClymont. He was really the father of sustainable agriculture and sustainable agricultural development. And all of those principles have kind of set us up in where we're at for what research we do, both Pete and I, but also everyone that works within rural science and teaches within rural science, or the Bachelor of Agriculture or the Bachelor of Agriculture and Bachelor of Business, all have this same ethos of how do we manage agriculture in a sustainable way so that we can manage the whole system for long-term prosperity for agricultural industries.
Yep. And both, a big program there for the meat side is ICMJ. Pete, do you want to touch on ICMJ? What is it, and what is what the program actually? What do you get out of there?
Yeah, so the ICMJ has been running since 1990. So in my role here, I take a team from UNE, but also president of the association. And so, when you talk about intercollegiate meat judging, you're like, wow, what is that? And realistically, it's not really about meat judging. Meat judging is the carrot we use to get people to learn a little bit about, what drives carcass value before they get to the conference, which is, quality and yield of a carcass. So we use the competition as the carrot to both attract them to the program and then get them to learn something. So when we go to the conferences, and then when the speakers talk about different aspects of that, then the delegates have got an understanding of what they're going on about. So it's been running essentially. Our motto is inspiring and developing future industry professionals for the global meat industry. So it's really bringing people in and showing them about the meat industry. Because if you think from an outsider, you think, wow, the meat industry is just, cutting them and packing them, and everyone's on the slaughter floor or boning room floor. But in reality, it's such a sophisticated industry. There's so many roles across the industry, from livestock procurement right through to marketing or the arts and craft department. So we try and bring the undergraduates into that space and educate them about the variation in roles that exist in the meat industry. So converting that animal into food, because we're all in the food production industry, whereas realistically there wasn't a lot of people that considered a career in processing or meat marketing. So that's where it started out, and now we run 2 conferences a year, one in Rockhampton, one in Wagga Wagga, so spread across the country. And in the Northern Conference, we also bring in industry delegates, so young industry professionals. And because some people can leave school, work in beef production or sheep production, and never see inside a processing plant. So they're producing an animal that has to be consumed by someone, and they're expecting someone to pay really good money for that meat, but they've got no idea how what they do on farm connects to that consumer. So we're trying to bridge that gap and broaden their knowledge about how, genetics and nutrition and animal management and health and disease, etc., on farm have such an impact on what the consumer demands, what they're willing to pay for, why our traceability systems are so important, all of that sort of thing that makes gives value to our consumers. So yeah, it's been a successful capacity building and capability building program for the meat industry for many years, and we're heavily funded by our 2 R&D corporations, MLA and AMPC. And it's a fantastic program to be part of. And so both Sam and I were on the Australian team back in the day. So Sam was actually on the last winning UNE team back in 2006, and this year 2023 UNE got the win again at the national conference in Wagga a couple of weeks ago, and
I'm pretty sure that British Genetics were the major sponsor of that one too, weren't they?
Yeah, absolutely. You can see
Don't plug him anymore. He gets enough plugs.
The Breeder Genetics logo. So Breeder Genetics certainly and Nola both supported our team to make the journey down to Wagga this year. And it's companies like that. We take the piss out of them, but someone has to support them to get there. And show interest in the youth of today. So we took a team of 12.
So Pete, how long has ICMJ been running, and are there any other notable alumni like that?
There's so many. So we moved. It used to be just a one-day competition. So we used to travel all the way to, it's been in Sydney and Yanco and Wagga. Back in the day, I competed in Wagga. We drove all the way one day, competed the next day, had a dinner that night, and then drove all the way home. And that's really not sustainable. And one of our life members, Peter Wynn, changed that program in the year Sam competed, 2006, changed it to this longer format, which was originally held here at UNE. And now down at CSU. So our requirements for holding the conference are pretty unique. We need, an abattoir not too far away, and lecture theatres, and then this room to do the workshops. Jason Strong was my coach in 2003. He was the coach for many, many years of the Australian team. Sarah Strawn was involved for many, many years as well. There's Troy Setter was on the Australian team. Gary Edwards back in the 90s was on the Australian. There's so many littered across industry. And I think moving to the longer format, everyone now gets something out of it rather than just that top little group that goes to the US. Now, all of it's a 5 and 6 day event. Everyone that attends now gets so much value out of it. And there was an awesome article out yesterday on Sheep Central from one of our delegates this year, just saying, everyone in the supply chain should do it. Now, that's probably a step too far, but I really appreciate someone else blows your trumpet. It's a good thing.
there is a range of people. I dare say there's not just one degree that going through. You guys are coming from two different backgrounds in terms of your actual direct studies. There's a whole range there. How many people are in the team, Pete, and what are they actually? What areas do you come from there?
So essentially, we probably have about at Northern, we got up to 120 delegates at the conference this year, and at the national in Wagga about 140, 150. And essentially, we're trying to, because we go off, look at Sam and I, we've gone off into wildly different areas, but we've all got this greater understanding of what drives value out of every meal. And we don't really care where the people that come to the conference go to and work in, but everyone's got this insight into what drives value out of red meat. So, and that's what we want to do.
Yeah. And Sam, can you tell us about the process? Pete mentioned the US. Where does it actually go from having this winning team that's Breeder Genetics sponsored? Where does that team now go? What's the process?
Yeah, so the process has been pretty similar across the time period, where there's a group of people that are taken from the national conference to a training workshop in Brisbane, where they learn about the whole supply chain, whether it be from the processing sector right through to the product development sector. From that point, an Australian team is selected, and then they go over for a tour over in the US. So I remember when we went over, it was right in January. It was super duper cold, and there was blizzards on. You go around in a bus with 5 or 6 other people, and so you spend the month hanging out with these people in really close proximity. So you get to know them well. I went over with Sarah Strawn, and it was a really, really great opportunity for someone just at the end of a degree to get to meet so many different people, and it really set up for me an interest in beef production. I really like it, and I'm sure it did for Pete too, because he ended up in that meat space. Is that still the same, Pete? Has it changed much since?
No, we're probably in the US now 3 weeks. Probably heavily focused now on those industry tours more so than training. Strongy was our coach, and Beck Underwood, and geez, we trained a lot, but we got pretty good at it. But now we really go. They visit so many different places. So right from food service, right down to production of sheep and goats, which is very different. So trying to give everyone that real broad brush of the American sheep and beef and goat industries.
So do they still go to the National Western Stock Show? That was so eye-opening. Do they still head there?
Yep. Yeah, so that's where the competition is at the back end of January. So the National Western in Denver, Colorado, there's 5 and 6 stories of cattle that get shown. It's just wildly different.
Can you tell us about dark cutting in carcasses? Obviously, that's something that would be brought up in that ICMJ, but can you tell us what it is and the grass-fed effects there?
Yeah, so I spent a bit of time in my PhD looking at that and a lot of research afterwards. So dark cutting is a condition where the pH is elevated in the carcasses, and so the meat becomes dark in colour, and therefore it's not ideal for consumer acceptability of that dark meat colour. But the higher pH also means that the micro grows a bit quicker. So because we live in Australia, 70% of our product gets exported. We need long shelf life on that product. So that high pH meat, which is a dark cutter, doesn't go into those really expensive value chains, mostly because of that micro reason and the colour and the acceptability. It also doesn't cook right. So when you cook it to the same internal temperature, of course, when you order a steak in the restaurant and you ask for it medium rare, if it comes out well done, you don't like it. If you order it medium and it comes out rare, which is what happens with dark cutting meat, you're also not very happy, right? And so if we're paying more and more for meat, we can't afford to have food service or chefs providing that meat to our customers not cooked to the right degree of doneness. So essentially, we want those. We measure the pH on every carcass that's MSA graded. and then they come out of that top tier, or they become ungraded carcasses. So what drives it? Two things really is nutrition of the animal, because that's our muscle glycogen level comes from our nutrition. So I've done one lecture today and sat here in meetings most of the day. So my glycogen levels are definitely maximized today. But if you've been running around a sale yard or doing something and you haven't eaten lunch, then your glycogen levels will be a bit lower. And as soon as you eat, you'll top those back up.
I've definitely been very slow today. I've been running around 160 heifers trying to put them on Oxygens Plus. So I haven't eaten all day, so I probably do need to.
Yeah, you're probably running low anyway. So nutrition's the most important thing. We can't see muscle glycogen in an animal. So that's probably the issue. When we look at a mob of cattle and we're like, oh yeah, they're still fat. Fatness doesn't equal glycogen. So we want them to be growing in those last couple of weeks before we exit the feedlot or grass-fed. Grass-fed animals are probably worse for dark cutting. And so we want them kind of growing at 800 or grams a day or more, because that means that they're getting enough energy to maintain themselves and grow. So their muscle glycogen should be pretty high. Then, if we've got them growing and we send them off to slaughter, we then got to minimise the amount of exercise and stress in that period between just disturbing them from underneath the tree and getting them to the knocking box. So we lose control of them as soon as we put them on the truck. Who handles them? What pen do they go in? All of those sort of things. So one of our most important things is minimising time between the paddock and the knocking box as much as we can, because reducing time reduces opportunity for stress, because we can't control everyone that deals with them around that period. So get them growing fast, minimise time to the knocking box, get rid of overnight lairage and things like that as much as we can. We'll minimise our dark cutting. Of course, grain-fed animals are much lower risk of dark cutting than grass-fed, because they're kind of habituated to humans. They've been on a truck before. They've been in a new environment before. They're not as naive as what some of our grass-fed animals are.
Yeah,
so
and I guess that also links into a bit of what Sam does with docility. If you have low docility, like high docility cattle, and your docility changes, it'll directly affect that pH and their temperament within their handling. So it all comes around again.
Yeah. So Pete, is there anything that we should keep an eye out for? Like sometimes you just got to manage animals and weigh them and all those sort of things. Is there like some time frames or anything that we should be aware of that can kind of fill that bucket that you referred to up again, so that we don't have kind of dark cutting coming through after our management, because that's what we might have to do.
So typically we say if animals are on really good nutrition, it takes about a week to make sure the glycogen's fully maximised. In Western Australia, we did some research over there where cattle were on dry feed. So at the end of spring, where all the feed just cuts out in one hot week, it goes from green to brown, there's not enough energy left in that green feed. So in that last couple of weeks before we exited the animals, we essentially fed them about 2.5 kilos of pretty potent, like 12.5 meg or 13 meg of energy pellets. So very high in grain. Didn't give them acidosis because it's only 2.5 kilos out of their whole daily intake. But what it did is it just topped up that glycogen in the last couple of weeks. If we can't really feed at the abattoir and top that back up, we can deplete glycogen 10 times quicker than we can replete it. So essentially what we can deplete in an hour takes us 10 hours to replete it. So we can't catch up essentially by feeding at the abattoir. We've got to have them really good before we exit the pen or exit the paddock, and then minimise that time to get to the knocking box.
Is it the stress, like in our sale yards, and I work all the time, we're talking about hitting cattle with sticks and things before they think, and we try and obviously tell everyone to avoid doing that. Is it the actual impact of a stick, or is it just the stress that animals go under that changes and makes a dark cutter, or is that just bruising?
So, yeah, good question. It's not bruising. So it's the pH of the meat that changes the refractance of the light through the meat, and so it appears darker, and it changes the water holding capacity of the meat. So you've got essentially glycogen is our muscle sugar. So after death, the glycogen continues to metabolize and produces lactic acid. And when you're playing sport or whatever and you run really fast and you can't get enough oxygen in, then your muscles start to burn. Now that's lactic acid that's doing that burning. So when we slaughter an animal, they can't breathe very well either. And so the muscle continues to produce energy because the muscle still thinks it's alive. It doesn't know it's died at all. And it produces energy in the absence of oxygen, which produces lactic acid. So the pH of our muscles now, as we sit here talking, is pretty neutral, or the pH of animals is pretty neutral, around 7, and we want that pH to be below 5.7. So we think of glycogen like the fuel in our car. If I've got a full tank of fuel, I can drive from here, Armidale, to Sydney pretty well, and I've still got some fuel left when I get there. And that's like driving from 7 down to 5.5. If I've only got a quarter of a tank of fuel, I'll drive from here and I'll probably run out of fuel around Gloucester, and then I'll have to go out to Moppy and help them draft some bulls or something. But that's if it stops at a pH 6 or somewhere along that journey down to 5.7, which is the magic number, then that's classified a dark cutter. So we need a full tank of fuel at the time we exit the paddock or the pen.
And is it always, go back to a bit that docility talk we were talking about. I know recently at Sydney Rural Show, and I might get killed for saying this, but there was quite a few dark cutters. They're very handled steers. Is that probably the trucking process, or what is that? They're cattle that have been broken into lead. They've been exposed all week at a Sydney show. Is the exposure to Sydney? What would bring those in for show steers?
Yeah, good question. So docility is important, and we've made some great advances in many breeds across time in docility, particularly in some of the breeds that had an issue like Limousins. But Angus have done a lot of work on it as well, and there's a whole raft of them that have. So docility is important. What you're talking about there with show steers is another really interesting part of it. So these animals have all been handled like they've been really babied, right?
Yeah.
And they've had the run of their own pen themselves, so they all think they're king shit. Yeah. So when you then put all these very naive animals back in a social setting together, they essentially re-rank the whole time they're in that pen together. So they are bashing each other up, chasing each other around for that whole period from when we put them on the truck and take the hackamore off them to when we get them at the knocking box. So show steers, basically what we're doing is every individual is a mob. We're mixing lots and lots of mobs together, and we all know how fun that is. And they just bash each other up to get their social hierarchy sorted out again. One of the great show steers I had when I was a kid was a really, really quiet steer. Like, he was an absolute cracker, got a broad ribbon, etc. Everyone was really excited about him, but he was an absolute baby. Like he couldn't defend himself to save himself, and he just must have got pizzled all night. And cut as black as Jack's jumper.
It must have come up after his owner. He must have just chased her straight after that, wouldn't it? Something to do with the bloke that broke him in.
No, he was quiet. I couldn't say the same for him.
Yeah, that's what it's always. So it's more. It's not the stress of the week of the showing. It's more at the end, right at the end, when they're all putting together to get along.
Yep. Yeah, spot on. And so what we can do there, we have to put them on a truck. We have to transport them. We have to take them to a new lairage facility at the abattoir. Time is our friend. So between putting them on the truck and putting them in the knocking box, we're running a project at the moment on time in lairage, and we just had our first kill today. But essentially, we're dropping them there a couple of hours in lairage, so they cool down, have a drink, get washed to get some dags off them, and then not that you have to do that with show steers, they're squeaky clean, but and then get them to the knocking box as quick as we can would be the only way you can really manage that.
Pete, we'll dive into the yield versus quality argument. You gave a seminar at the JBS night down in Melbourne here a few weeks ago. Good article came out of it in Beef Central. I suppose, where are we in terms of yield versus quality? But can you touch on some of those output measures you mentioned in that talk here.
Yeah, thanks, Jack. For many years, the question has been around what's more important, yield or quality, and I guess the approach we took to that paper that John Thompson and I published last year was around, if we vary quality and vary yield, does the primary driver of value shift if we move quality? And the long and the short of it is yes. So in lower quality animals, so the average of the animals that we boned out was around 57.5 MSA index points. In those animals, yield drove most of the value, particularly if we don't differentiate on quality. So I know this is mostly a beef podcast, but in the sheep world at the moment, we don't differentiate anything on quality, right? So yield is the primary driver of all value in a lamb carcass or a mutton carcass. In beef, we've got better at branding over the last decade. And so we're segregating out those higher tiers of meat and selling them at a higher price than the middle tier and the lower tier. If we don't do that, then 97% of the value out of a carcass comes from yield. As soon as we start segregating brands and selling brands for different money, then quality starts to drive a little bit of value. In lower quality animals, even if we fully segregate everything, there's not that much that goes into those top brands. So yield still drove about 70% of the value. When we then flipped that on its head and we had really high quality animals, so only a 62 index, so it's pretty similar to some of those good grass-fed programs we see out of the south or a non-HGP grain-fed program, then if we segregated out all the cuts and sold them for their true value in terms of quality drove 70% of the value and yield drove 30% of the value. So it flipped it. It was the inverse. And so there's this real dynamic relationship between quality and yield in what drives value. So in higher quality animals, quality drives it. In lower quality animals, we should be using every technology we've got, like HEPs, et cetera, to drive as much production out of them as we can, because yield is the primary driver of value out of those carcasses.
So then, Pete, to say yield is still king, do you still believe that?
Depends on who you're producing meat for. So if you're aiming at a Great Southern, like I was talking at that event, yield is not king because they segregate and they've got Little Joe's and Pinnacle and Great Southern. Quality drives 70% of the value out of those animals. So yield is still important. It's still driving 30% of our value. Most of that's driven through weight and eye muscle area and conformation. So yield is important, but nowhere near as important as quality. But in a lower quality animal, it's no point putting all your emphasis on quality either. Let's say if you've got an animal that's only ever going to peak out at 57, 58 in terms of index points, there's no point in spending, a gazillion dollars on a really high marble bull because quality is not driving value in that sector or that type of animal.
Sure. And so with some of those branded products, where do you see the future of that yield quality thing going? Are we going to see more separation of animals entering the marketplace? We have yield, we have quality, and that's it. Do you see a place for both of them working together? Where are you seeing the future of that argument going?
Yeah, look, absolutely. So in terms of yield, I often get asked this question, but I think the simple answer is giving feedback back to people and then people being able to see the normal distribution of their animals. Even if we don't pay on it, we don't take any notice of it, we'll be able to trim that tail. So those really low yielding tail, you'll be like, wow, who is the mother of that calf, and get rid of them, and then that just shifts that normal distribution up a little bit. So even if the industry never pays on yield, the knowledge about which ones are our better animals and our worse animals, getting that data back to producers so they can do something with it is really important. So that's even well before there's a value-based marketing system, just getting, because at the moment, what do we get? P8 fat and carcass weight. Now that describes carcass yield. The R squared with carcass yields about 0.2 at best. So you're capturing 20% of your valuation in yield. So you may as well chuck it over your shoulder, and that's what most people do with it. Do we fit the weight specs? Do we fit the fat specs? And they don't care about what percentage of meat got sold out of those animals beyond that. So we're at the very early stages, I think, in understanding variation in yield across our industry, and then what we can do with it to improve it. I'm excited about some of the work Sam's doing around efficiency and methane per kilo of, once we work out whether it's per kilo or per animal or whatever it is, but if it's per kilo of meat produced, it'll be those animals that have got fat in the right spots with plenty of meat as well that'll rise to the top in that analysis. I'm pretty sure of it.
Yep. Yeah, sure. No, that's great. Great. And so on the production of meat and where things are going, where do you see the future of that alternative proteins and beef versus other proteins? How do we, as a beef industry, stay relevant?
Yeah, good question, Jack. We're never going to win the battle on price, right? So price is, as Warren Buffett said, price is what you pay and value is what you get. So we have to, and MLA's been on this for a long time, we have to drive value out of red meat. And value comes in that it's really nutritious. It's really enjoyable. It's a celebrated meat. The kids eat it. That's a good start. The versatility of it, how quick is it to cook? All of those things drive value far beyond just the price. And so we have to continue driving value out of red meat going forward, because we never want to win the battle on price. We've got a high cost of production, and we produce relatively, in terms of world scale, a small amount of the world's beef, right? 3 or 4% year on year, depending on what our slaughter numbers are. So we essentially need to produce something that matches our cost of production, which then comes into being very high quality meat. What is high quality? It might be clean and green. It might be, low micro count, long shelf life. It could also be around the quality of what we think about. So really tender, really juicy, really flavoursome. So, where are we going? We've got to continue providing high quality product, because our cost of production will never slip. We'll never win the value on price. So we've got to win the battle on value.
Do you think on labeling issues kind of front, Sam, probably even within the breeds of the beef industry, do you think we need to become a bit of a united front there on the labeling of on meat? We see a lot of this branded stuff for a specific breed. Does it need to go back to maybe something like the land-based thing to say, hey, it's just beef? That's what it is.
Yeah, I'm not sure. I think the branded products have a space because they're a way of getting value for the given product. So that it's a way of differentiating in the market to explain what quality is. And as long as the system pays for that extra value, then it's a good thing. Some of the challenges that we do have is that alternative proteins try and use the same branding strategies as what we do for the meat-based strategies, and so it's differentiating ourselves importantly from those, so that it is not the alternative proteins piggybacking on what we do in meat, rather than us standing out from the crowd in a sense in that space. So I think it's really important that marketing around what we do and all the good things we do with beef, how it's a natural green product that takes grass and turns it into a really edible, nutritious meal. Those sort of messages are really, really important to keep front and center for beef production.
Yeah, you don't see too many Hereford soybeans, do you?
No, Hereford soybeans and lab-grown beef. Well, that's really challenging for me because we've got this natural, green, healthy product that we can produce, or we can actually produce it in a petri dish. Well, that seems a bit counterintuitive to me to what is actually good food. I'd much rather take the beef any day.
On that space around alternative proteins, we see about 7% of our population identify as a vegan or vegetarian. But when we boil down to it and do a survey in a particular way, there's really only about 4% that are truly vegan or vegetarian. And the other 3% are what we call flexitarians. So they sometimes eat meat. So they like to identify one way, but realistically, they kind of flip and flop a little bit week to week and what looks good. And that number really hasn't shifted. Although, the advent of social media, they can be quite noisy. The percentage of people that are in that category really hasn't shifted over the last couple of decades. So MLA's done some research on that for many years, and it really hasn't shifted across since 1998. So do we have to be worried about it? People need options, and sometimes that vegetarian option allows you to take a whole family to a restaurant, and so the one vegetarian kid or the sister-in-law or whoever it might be can eat there as well, and everyone else gets to enjoy what they get, and they have a good meal as well. We're in a pretty lucky space at the moment in terms of red meat, that we've got a burgeoning middle class in developing nations just north of us in Asia. So, whatever our market doesn't soak up, we'll find a home for around the world with not much hassle as our population grows, still over the next 30 or 40 years.
Yeah. Do you think that there's possibly something producers can do to compete, like to help compete? Obviously, as front across the industry, we need to compete. But is there anything specifically to producers they can do?
Yeah, I guess just continue telling our good story, that it's coming to the fore actually in this whole carbon debate that's happening now, and that carbon's in a cycle in primary production systems, and farmers, we were the enemy a couple of years ago. Now they're looking at us like, hey dudes, we really need you to keep sequestering carbon in the soil, in the trees, in the plants, in the ground as roots. So we continue telling our good stories about stewardship of animals, stewardship of our land, what we do to provide it to the next generation in better health than what it's in now. There's so many good stories in agriculture, and it's just about, continuing to tell those stories. And there's some great programs around, and we're getting some influencers on the bandwagon as well, and so they've got a whole audience that we don't connect with. No influencers follow my social media, but if we get into the right channels, then we can influence a whole group of people that probably wouldn't get that knowledge about how much we truly do care for our animals and our environment, because we know deep down that what we do this year affects what we do next year. Now, look at how people cared for their heifers and things in the drought of 18 and 19. They knew that was their livelihood when they came out of that drought in 2020 and 2021. So they looked after that nucleus of heifers. We inherently know what we've got to do to look after our production system.
We've nearly got to take the professionalism out of it, I reckon, a little bit too. Like, I know my brother actually lives in Sydney, and there's a conversation had on a bit of a dinner table. I'm going to throw him under the bus, but we had a conversation about the whole methane. I think we're going to touch on that a little bit later with you, Sam, but we talked about that and the way everyone's talking about climate change and that big movement, and we talked about the production, and this alternative idea came up of alternative proteins and all that, and about greenhouses and trying to put more trees in. It's just what's kind of plugged in to Sydney, I think, and what is, those big metropolitan areas have got that plugged in, and how we go tap with that. Can we really compete with it, or what is how do we do it?
Well, that is a challenging question for everyone to think about. What it's good to step back and think a little bit about the cycle of what happens in a cow, mainly because a cow doesn't produce anything in a sense. It only turns a solid form of carbon, which is in a plant, which has been turned from a gaseous form of carbon in CO2 into the plant, and then changes it into beef and burps a little bit out as waste. So the beef that we eat is a carbon source in its sense that's just been changed its state from grass to the state of beef. And then a little bit of methane that's burped out is broken down into carbon dioxide, and then it's turned into grass again. So there's a whole cycle around how carbon is cycled through the system. That's the first thing I wanted to highlight, just because often people will think in terms of beef cattle that they really produce the methane themselves, but it was just turned from pasture back to the air and then back around again. So it is a relatively closed system. So how do we actually slow the amount or make sure less goes into the atmosphere? Well, some stays in beef. Well, that's a good spot. Stays in people once we eat that beef as well.
And so we've seen our industry open up a little bit. Like, when we were kids, we could go through the abattoirs and see the carcasses and things, and then we just shut that place down. Don't let anyone in. Don't let anyone see what happens inside a processing plant, etc. Now, over the last couple of years, I was over at Casino Beef Week earlier in the year, and NCMC just opened their doors to the public. There was like 3,000 or 4,000 people that went through and saw what happens inside there. So little changes like that engages the audience, shows them how technologically advanced it is to produce that steak meal. I'll give you a little insight into. I lived in Fremantle in Western Australia for 10 years, so I dealt with city folk for a lot of time, and we had some great chats around the kitchen table and at the yoga studio, etc., about what is agriculture and all this sort of thing. And one of our housemates brought home a girlfriend one time, and she had no idea. And we were sitting there, and she was really trying her best. And she said, "So, when does lamb become beef?" And and that was one of the quotes that was on our fridge for ages. Just about stupid stuff that people said, but that's how far back some of our population is. So even educating them about that we grow these sheep and we grow them out to a certain age and then they become lamb. That lamb isn't baby lamb. Like, all of that stuff is so important. Like, simple stuff for us in the industry, but so important to the broader audience.
Yeah, sometimes, Pete, I think it's also good to think of it as an opportunity. So things around people's perspectives around how food's produced isn't all. It can be challenging at first, and the initial reaction when everyone's challenge is to defend a little. I think sometimes it's good to step back and think, well, what opportunities can we have from the changing landscape that we see in society for beef? Because there are lots of opportunities as well. Those opportunities that we've talked about, making sure that we have a clean green product that is high quality, that is used at special occasions so that we can extract value from that whole chain. Well, that's actually a huge opportunity with this society changing, in a sense, that we don't have to be a commodity-based product. It can be for some things, but we can leave that to the alternative proteins. They can be the commodity-based product, and we really are trying to extract that higher price and higher value for our industries.
And with the methane work that's happening there, guys, what's the actual research currently in the space, and what's happening and where's it up to?
Yeah, thanks, Jack. I guess I'll take that one, Pete. Just lately, I've been doing a lot of work with methane. We've got a main project which is around trying to think of genetic technologies that we can develop to help people select for low methane emitting animals, and to include traits like methane in a breeding objective, so that we can have a well-rounded breeding objective that includes meat quality as well as growth and reproduction and methane and feed efficiency and all those types of traits. And so there are really, if we think about it, there's two main levers that we can pull, or alternatives, ways that we can start to measure methane and deal with methane for beef cattle. So the one that I have done a lot of work in is genetics. So what can we do? We can start to measure individuals, understand the individual variation that there is in methane, and there is quite a lot of individual variation. We can have animals producing 50 grams of methane per day right up to a couple of 100 grams of methane per day. So there's this huge amount of variability. We have to start to capture that. The way to capture that is measure individuals. Once we measure it, we have to evaluate it. The way we can evaluate it is make genetic evaluations. So whether it's through tools like BreedPlan, or whether we can add genomic predictions to tools like BreedPlan, which are commonly used through evaluation systems, and then we can decide what we're going to select on. So we can select on animals that have lower methane emissions for the total product quality and product that we can produce. There's also the rounded objective part of that genetic story in a sense that if we have cows that produce lots of calves, then of course that's going to reduce methane per unit of beef, because we won't have a wasted cow running around on pasture producing nothing except methane. So that fertility story in a breeding program is really even more important when we get to having sustainability-based traits like methane in there, because they're just such a waste. They just keep pumping out these waste products like methane, using up feed. We really need to have those cows having calves. The other way to manage methane is by feeding animals different stuff. So both are really, really important. So genetics is a long-term permanent cumulative solution, but it'll take a long time for us to reduce big proportions of methane. Thinking like 1% reduction per year, and after 20 years you get sort of 20% reductions. Whereas we'll need some tools or some equipment essentially for the short term, and that's where it comes in. What do we feed these cows? Can we feed them some supplements? So some of you might have heard of the two big supplements, so seaweed and 3-Nop or Bovaer. So those supplements are something we can feed animals to make sure that they don't burp out as much methane. We could also look at pastures. So if we had novel pastures that had components in them that could reduce amount of methane, there's some natural pastures out there that can do that. We can also make sure we have high performance pastures, so we're putting on as much meat as possible in the shortest amount of time, so that the animal isn't here wasting a lot of resources burping away for a long period of time. We actually harvest them much, much younger. So that's really the space. And there's a lot of research happening in both of those spaces. So the genetics space, as well as that supplements and pasture and feeding space. And yeah, what else would you like to know, Jack?
Sam, I've got a question. It's early days, but like if we go 1% down genetically over time, do you reckon there's a flaw in that? Like, do we get to a point where we're like, we really have to drop growth rates or drop other traits in the pursuit of lower? I know it's early days, so you can just say,
No, it's a really good question. It's probably one of the most common questions I get asked about methane is, what are the correlations with other traits, and are there limits to it? So there's been some work. So there was a big MLA project that had New South Wales DPI and UNA and a few other partners, CSIRO, as part of it, called the National Livestock Methane Project Number 1. A nice, unique name, I guess. But what it did was it measured around 1,000 animals for methane as well as some productivity traits. And the initial estimates from that, it's a smallish study, were that yes, methane's correlated with growth. Yes, it's correlated with the amount of food animals eat, which makes sense from a logic point of view. But from a quality point of view, it wasn't strongly correlated with meat quality and meat volume. And you could come up with traits that weren't. So traits like residual feed intake that have been used for feed intake, we can make traits like residual methane production that allows us to select animals that still grow, but also have less methane for that amount of growth. So you can have a whole rounded breeding objective that includes methane. The important thing to do is to still record everything else. I think we'd really quickly end up in a pretty crappy position if we went and said, oh, well, our only objective is to select for lower methane emissions. I think that could be really
single
dangerous.
trait selection. It's gone well in the past.
We would end up with an animal that is pretty undesirable. So what goes along with all of these methane projects is still recording productivity, still recording meat quality, still recording fertility, so that we can understand better the relationship between traits, but also understand better how the direction of selection could matter and how fast we can go in certain directions. In terms of that secondary question of can we run out of genetic variation and will it kind of plateau, it's a hard question to answer because variation can change as animals become kind of more uniform or more inbred over time, and selection leads to that. What we've found in a lot of selection experiments, so there are quite a lot of long-running selection experiments that look at traits and try and form some theories around how much does it run out, essentially. And so the most famous of those is a corn selection experiment running out of the US that have been selecting for a rounded breeding objective for yield over 100 years. And what they've found is, well, yes, genetic variation reduces a little bit, so the number of lines has reduced, but the total genetic response has been as we would predict. We haven't run out of genetic response. We have new sources of variation that come through over time, and that we haven't lost variation in a sense. So we're still making the predicted amount of genetic progress that we were predicting in the initial phases of those projects. So I suspect that, yes, there probably is a limit, but that is probably a long, long way down the track after many, many, many generations of selection, like hundreds of generations of selection, rather than just a few generations of selection. Because they've got 100 generations of selection, there's still lots of variation, and they're still making good genetic progress. So I suspect that that's the case with methane, that it'll take a long time to use up that genetic variation, and we should be pushing more and more and adapt as that comes, rather than thinking, oh, well, let's not do it because we may one day reach a floor, in a sense.
Sure. And so you speak of those genetic correlations. Can we actually select for methane, and have we got any heritability estimates around it yet?
Yeah, so it's a good question. So from those initial projects, they only had around 1,000 records. So we have some projects in the south and in the north that are around collecting lots of methane records from the reference population projects that exist. So for those reference populations include like the Angus Sire Benchmarking Project, the Southern Multibreed Project, the Repronomics types projects in the north. And what we want to do is build this big reference data set of animals that have methane as well as all of the other traits. Because those initial estimates are only on 1,000 animals. We're not super confident on those estimates. And so we need to have more data to do that. But if I think about where those heritability estimates were, that they were definitely heritable around that 0.2 to 0.3, depending on the trait definition. So we can definitely make genetic response. That's where the 1% genetic gain per year comes from, was knowledge of the initial estimates of heritability, etc. So we have some of that knowledge that can tell us, oh yeah, we can have a ballpark figure of about that 1% and be relatively confident. And that's a pretty conservative estimate of how much we could change the trait because of that previous data. But of course, we're in the first year of our big project, and we have another couple of thousand records coming through each year. We'll find out a lot in the next year or two, so that we'll be able to report back to you, Jack. You'll have to have us back.
More than welcome back, I'm sure. Maybe next time we need sit around a fire with a few beers and solve the world's problems then.
I've got some samples in my fridge but if you're all here, we can
pass them through.
And so then, Sam, you mentioned, building that reference population. How, moving forward, reference populations and more so genomics will have to be a pretty strong tool for producers to use at an on-farm level. We'll dive quickly into the genomic and reference population thing, but this is obviously a lot of your space. Can you tell us, I guess, a lot of people probably understand what a genomic is and a genomic test is, but what the other side of the argument is a reference population. Can you kind of just talk us through how those two interact and kind of what I suppose the actual number side of a genomic evaluation and a genomic test is?
Yeah, it is a good question, and it would be good to expand on it a little bit. So often genomics has given us an opportunity to DNA test a bunch of individuals, and probably the most common perception is that we can DNA test some animals and understand genetic merit in some way. Now, to allow us to understand genetic merit in some way, someone has had to measure some animals somewhere. Now, those animals that are measured have to also be genotyped to link to that animal that you've just genotyped and you want to get your prediction of genetic merit from. So those animals that are genotyped and also measured, we call that a reference population. And that reference population it's kind of a new term, but it's not really a new concept, because in genetic evaluation, any animal that used to be recorded and have pedigree information was really the reference population for an EBV. Now it just kind of disconnects, in a good way, the animals that you have to measure and then those animals that you want to select. So it opens up this whole world of possibilities of we can measure and genotype a group of individuals that don't have to be our selection candidates. They don't have to be the bulls that you're going to sell. They could be a group of progeny tested steers or a group of well-recorded commercial animals that we know something about their environment as well as their genetics to underpin a test. So that gives us opportunities to be able to design these things, whereas those opportunities didn't really exist for traditional pedigree-based genetic evaluation. So when we design a reference population, we're really thinking of how can we predict the animals that we want to select well and accurately. So to do that, initially, reference populations can be pretty small, and to get an accurate estimate, you try and measure animals that are closely related to those ones you want to predict. But as the reference population becomes more developed, you can start to get a bigger reference population, and it starts to matter less whether you are really highly related to the reference or not, and you can start to predict a breed base. So if you've got 200,000 records and they've all got good phenotypic records as well, that is your reference, and you can use that to predict your new selection candidates. And those selection candidates, they don't have to be 2 years old. They can be 3 days old or a week old, and you can start to have good, accurate selection decisions really at an early age rather than having to wait until they're 2 or 3 years old. So I hope that kind of meshed a few topics there, Jack, of what is genomics, what is reference populations, and then how could you use it within a breeding program?
Sure. No, thanks for that insight, Sam. And we might we'll keep moving on now to one of my favourite parts of the episode, the rapid fire questions. And the aim of the game here is short and sweet. Yes, no answers are accepted. And so we're going to start off. We've got a few questions here, all ranging from all sorts of things. And the first one I'm going to ask is a little bit left field, and maybe you already answered a little bit. But why should or shouldn't I go to university?
Look, I think it's about, yes, what you learn how to learn. You learn how to ask the right questions, but it's also about your network. Look who's around you, whether you get that network from things you've done in terms of your breed societies or whatever. But university gives you a whole new network. And a lot of your mates from university, they've gone off into accounting and being a lawyer and being this and that and whatever. And you need all of that. We need all of those people in agriculture as well. And so your network from uni days is so important.
I'll add to it that it's also so that you expand that network. So often when you're young, it's hard to step out of the network that you've already set up in, whether it's school or family and those type of networks. So sometimes there's a risk of being in kind of a vacuum. You start to regurgitate what everyone else tells you. Whereas coming to university, you meet a really diverse range of people. You study a diverse range of topics. Whether you like those topics or not, it actually doesn't matter too much. It's more the process of actually learning that there's other stuff out there. There's a whole lot of other stuff out there, and you'll be able to find something that interests you. If you don't come, then you can often get caught in that space of only thinking the world's this big when it is a really big place.
Yeah, it's very true. I grew up at Wallabada, so it's a small world.
Sure. Well, move on to the next question. One that was asked a little bit. So all these questions came in from listeners on a survey, and this question was asked a little bit, and it's how do I measure tenderness in live animals?
Good question. Age.
Short and sweet.
It really is. So the relationship of one muscle to another in an animal remains relatively constant as an animal ages. So muscles don't really re-rank in terms of their tenderness hierarchy, shall we say. But as we get older, they all get tougher because we build our what are called the collagen crosslinks between our muscle fibers, because when our muscles contract, they need to pull on something. And so they pull on the collagen, and the collagen connects on the tendons, and then the tendons pull the bones, and then you move forward, because our muscles are really there to do mechanical work. And so tenderness, the best way to drive tenderness is age of the animal, and then the next way is around marbling. So marbling, when we get really highly marbled, or even any amount of marbling, kind of dilutes out that connective tissue. When we get into really highly marbled animals, it actually dissociates or kind of frays that connective tissue, making it quite tender. So that's why, in the Wagyu breed, they're really quite old by the time we kill them. Their ossification scores are through the roof, but that meat's really tender because the marbling kind of frays that connective tissue in the muscle in those really highly marbled animals.
Oh, that sounds like you're trying to have your cake and eat it too, Pete. Like that's saying have them young, but also let them be old and have lots of marbling.
Yeah, well, there's it's a bit like an index in a bull. Two bulls can have exactly the same indexes and get there via very different avenues. And it's like meat quality. So two bits of meat can have exactly the same score. One can be really, really tender but not have much flavour. The other one can be way more tender, but be a little bit tougher. So, and they get exactly the same score via very different avenues to get there.
Well, since you guys have just brought that up, we're going to skip a few questions and jump straight into the days on feed in the pursuit of quality. Are we losing efficiency there?
Yeah, this is one of Sam and my favourite topics. We discuss this all the time. So at the moment, we do a lot of measurement in the sheep industry, right? And we're seeing marbling in sheep at 7 to 9 months of age, 10 months of age, at 8 to 10%. They are babies, right? And we measure it in cattle when they're quite mature. So we've got to be able to, I think there's animals there that lay down that marbling earlier in life. So whether it's it's just different rates of deposition of those fat depots. So I think we use days on feed as a very, very blunt stick in our industry. As the pressure comes on grain availability, ration price, methane outputs, days on feed need to be really looked at and evaluated, because we've got away with it because we've got cheap ration price and expensive meat. So the pressure will come on days on feed in the future.
So yeah, I'll add to it, Jack. I think days on feed is a management tool to make up for poor genetics. I know that's going to be a pretty blunt one. Maybe that'll get a few people.
That's good.
The reason being is that at younger ages, you're going to have a little bit of some animals that are marbling well. But from a feedlotting perspective, we want all the animals to marble really well. So we try and make sure that at the cutoff, we might have only had a few at young ages, but as they get older and older, we get more and more that are above the line. So I think in terms of breeding programs, we really need to start to transition to what do we want our cows to look like in 10 years and start to measure traits like that. So if we expect that we need to start to reduce days on feed, the spot to do it is in those reference populations that we talked about. We should be looking for those animals that marble at younger ages and be managing those reference populations like we hope to manage our animals in 10 years' time. And that gives us that opportunity to find the good ones, make it, and actually improve the genetics and not have that disconnect between management and genetics.
Yeah, so I believe there's animals there now that we can get the same outcome on much less days of aging. We just, because of when we measure IMF at the moment, we don't know who they are, essentially.
Sure. So next question kind of is a little bit around this. So So much of the industry has invested heavily into carbon and methane research over the last few years. Do you guys believe other aspects of research and data collection has been forgotten, such as some of these feed efficiency, ability to select for animals that marble at a younger age, maybe some of our longevity traits or carcass grading technology? Do you think some of that stuff may have been forgotten?
Oh, you want me to go first? So, thanks, Pete, for leaving me to it, dropping. So, I actually don't think not so much. There's still been plenty of other work going on, and that's been in the important part. I can talk from the experience of the genetics projects, in a sense that they're not methane only projects. They're overlays on existing projects around product quality, product efficiency. Fertility, all the traits that, from a genetics point of view, are important for a rounded breeding objective. So they're not isolated on their own. They're actually as an add-on to stuff that we were going to do for productivity anyway. And I think that's been a good thing, is that it's not methane alone. It's actually overlaying it on top of stuff that works with productivity. And that's from my perspective, from the genetics side of things. I don't know. What do you think, Pete, from the meat science?
I think that the focus on carbon has been a great one for driving efficiency right across our production chains. Because as Sam pointed out before, the quickest way to make gains in terms of methane per kilo of product is make sure every ewe has twins, every cow has a calf every year, getting those off farm as quick as we can, getting them to the abattoir. So that's all driving efficiency. Yes, we've spent a bit on looking at red asparagopsis and Bovaer and that sort of thing to reduce methane, but it's actually channeled everyone's attention to making every system more efficient. And I think, that's kind of really old research, but it's really putting it into practice now more than ever. What sort of grasses do we grow? How much do they eat to grow a kilo? Like, how much do they eat to put on a kilo of weight gain? Like, all that is, feed efficiency stuff from way back, but it's bringing it to the fore when we start measuring it and calculating it. So I think it's bringing years and decades of research and putting it together in an efficient system.
On that too, it's probably that it in essence, it hasn't been robbing funding from other things. It's been actually a bit the opposite. It's encouraged investment in beef production for research that may have taken a lot longer to get to, because other people now have started to bring dollars that are not just from industry and not just for government to try and invest in products that might be useful for agriculture. So a lot of things. It's actually been a real opportunity for research as much as it could be a negative in a sense. It's been lots of new investment being pulled into agricultural research to allow us to understand the system better.
Sure. No, thanks. And Sam, this here is probably a question relating EBVs and one for you. And the question here is, how can we effectively measure longevity as a trait, and why don't we see more of an industry EBV for it?
Well, that's a tricky one. And I thought you said that these were meant to be yes/no questions. I don't know if I can do a full yes/no question.
Yeah.
For how do we select for longevity?
Can we do the trait? Yes or no? We'll start with that.
Is it important? Yes, because we want to make sure that we have cows that produce calves efficiently for a long period of time. Longevity is a tricky one for a breeding program. Mainly because when we select animals, we want to do it at a young age. If we wait for a long period of time to have accurate measures of how long a cow can stay in the herd, we have to stay a long time measuring a lot of unproductive animals as well for other traits. So there's this real balance of trying to get information on longevity, but also making selection for productivity at a young age. I think there's a real opportunity for reference populations there to be recording, maybe not even in seed stock systems, but more in commercial systems, to understand how long cows stay in the commercial herd and genotype them, and be able to select younger animals based on that reference population we have. So it allows us to disconnect that age problem that we have by trying to select cows that stay in, and in essence, they're going to be old. So yeah, that's where I think it's at. I think there's a lot of work to still do. It's still an important trait. I'll throw a cat amongst the pigeons a little. Some efficiency modelling that was done through the 70s, 80s were around heifer-only systems. So there are efficient systems where you can only you mate heifers early, you have them have one calf, and you only do it once. So some of those challenging systems, especially things like AI companies where you could have sex semen and have heifer-only systems for a big proportion of commercial production, may mean that longevity may not be important if you really chase that efficiency angle, because they were really, really efficient systems. More than happy to send a few old papers from some wild thinkers in a sense of how that could change breeding programs and production systems. But for now, I actually still think it's a really important trait, but it's around defining it, making sure we can select it young using genomics.
Is that one of the challenges as well, defining what to measure to call longevity? And does your idea of longevity, Sam's and Jack's, do they all differ?
Yeah, definitely. That's a great point. What is it? Yeah, we can say I don't know yet. I'm not sure.
Least weight, like growth is easy, right? Kilos at so many days, but longevity is, I think is the challenge is defining it. So what does it mean, and defining it for everyone, that we're all on the same page about what trait to measure. Yeah.
What's that age-old question? When should a cow be finished? But when's she in a prime, and when is she going to be actually finished? Should you still have a cow there at 13? Shouldn't she have better daughters in the system by then to replace her? And should she be out, or when's that? Exactly.
Yeah, that's one of the big challenges. Is if she's 13, why is she still there from terms of productivity too? But you have to wait to know how long she's in the herd to wait to 13. So then it's a real chicken and egg. Like, should you wait or should you select? We've done some work.
If she's still having her calf in the first cycle and she's knocking out a second calf heifer that's in the second cycle, maybe she is more productive.
Yeah. It comes back to that comment of should we design them for the future? Maybe in breeding programs, it's really challenging when you have to try and produce lots of bulls to make lots of money. But if you could shorten natural breeding cycles to be just a single cycle, you would actually put a lot more pressure on that cow, and the ones that do only calve in that first cycle probably are the ones kept. It's a challenge for a bull breeder though, because if you're only keeping those ones that are in calf in that first cycle, you might miss out on quite a bit of income from those bulls that are produced in that second cycle. So there's quite a contradiction in that system.
Sure, I think we could create a whole new podcast about maternal efficiency as a whole, and we've only just scratched. And maybe if people want to hear that, let us know, and maybe we need to do that. But we'll keep powering along. And Pete, now question to hit back into you: does Asparagopsis taint meat, and what do we know of its impact on meat quality?
Yeah, good question, whoever put that forward. And look, I think the jury's still out. We've got a couple of projects running right at this point in time. So one on domestic short-fed animals, so they were 70 days on it. Another one in mid-fed cattle, so they spent their last 100 days on Asparagopsis. And then the cattle from the recent project that's been in the media from AACO that spent 280 days on Asparagopsis. So we're putting all that to the test now around with consumers and using the MSA method. So yeah, results will be out soon.
Sure, perfect. Next one again for you, Pete, and this love to get your thoughts here. So, how does our industry move from meat graders to objective technologies? Should AusMeat push us there for the greater good of the industry, and if it is the greater good, or leave it open to market commercialization?
Yeah, thanks, Jack, and something pretty dear to my heart so I ran the eating quality project in the Advanced Livestock Measurement Technologies project for the last 7 years, and that just wrapped up, and hopefully it gets new legs. But we developed a lot of great technologies in that space, and I don't think we'll ever get rid of graders. These things are going to be tools for graders to use, right? Because we cannot quarter carcasses perfectly every time. So there's always those animals that are not, so the grader will have to override those technologies. So technologies for the quartered site will still be used by graders. So then you ask, okay, where's the value in using a technology? So it speeds the grader up a little bit, but most of the value is around the repeatability of that measure. Let's say you're a brand owner. You want the same quality meat in that box today as next month, as next year, as last week. And technologies are about, depending on the trait, but somewhere 30 to 40% more repeatable than our three best human graders. So, we've got value there, and if you've got multiple processing plants putting the same meat into the same brand, you can essentially have the same awesome grader at all those different plants on the same day. So I think market forces, we need to work out where the value is in having a more repeatable measure across time, and that's where technologies will really make their mark for our industry. So it'll happen. We're already seeing in the sheep space, we've got lots of MEQ probes around the country to grade individual sheep. We've got lots of plants looking at hot grading and also using technologies to grade carcasses. But so over the last 7 years, we've spent a lot of time developing and accrediting these technologies. Now where the rubber hits the road through commercialization and implementation. So those two phases of development of a technology aren't quick either. So, how does the data talk to the systems that already exist? How do do they need Wi-Fi? All of those sort of things. When it breaks, who fixes it? All of those company systems, how do you pay for it? What's the cost of it? All of that now gets worked out. So science is kind of done. And then we're moving now into that commercialization and implementation phase. So realistically, we're just seeing, it's just the tip of the iceberg in terms of objective measurement in our industry.
Sure. Well answered.
You're on mute, luckily, Sam.
Oh, was that a short answer or a long answer?
Yeah.
Well, just a bit passionate about that one.
No, very well answered and well said. And we'll keep things moving and get back into this. Do you guys think the industry should be pushing to allow gene editing? Is transgenics viable in beef production, given consumer confidence?
Yes or no?
um, I don't know if I'll go yes or no. Maybe. Gene editing isn't transgenics, so you've got two things kind of combined there. So gene editing can be used to change a region in the genome that's naturally occurring in that organism already. So in that sense, I don't have a problem with that component of gene editing. So if it's to change an animal that would have had horns to not have horns, but cows of that type could not have horns anyway, well, then I'm all for that, because that would be a lot quicker to do than conventional breeding. I still find it quite challenging for transgenics of including genes from other species. I think it's rightly regulated pretty heavily, and I'm not quite sure of the impacts of those sort of things socially as well as morally for those animals. So I'll sit on the fence for that one. But for gene editing, if it's naturally occurring variation, say like horn and poll, then I'd be happy with it as long as it's naturally occurring in that animal already.
I'm going to say no, Jack, to the transgenics, simply because we need our consumer to trust us, and I think we can make genetic gain in a natural way. Yes, it's slower than probably what you'd get from transgenics, but we could do a big lot of damage to our consumers. And remembering they're the only ones that put any money into our whole system. So if we can probably cut off our nose to spite our face, kind of thing. If we went down that track, we'd need to look at other ways of getting genetic gains.
Yeah, just gene editing is not always transgenics, though. So that's the important thing to differentiate between the two technologies. Transgenics is quite different, and yes, you can use gene editing technologies to do that, but you can also use gene editing technologies just to make natural changes that would have existed anyway. So
natural changes, I think, would be accepted, right?
Yeah, it would be challenging though to explain it to consumers though, and I think that's probably something that we have to be very careful of. Like Pete said, we don't want to turn people off eating meat because they think it's transgenics, and that might be an avenue people go straight to when it's not even that, and that'd be still bad. That'd be bad for our industry in a sense.
And Sam, sorry, just going to ask you another question there. You speak of the horned polled. What about some of our production traits like growth or marbling, EMA, whatever the situation there is?
The reason I picked horn pole is because it's a bit simpler trait. There's only a few known regions that control variation in horn and pole. And so it's already been done before. There's been dairy cows that have been edited to be polled in the US at UC Davis. And so that can be done relatively straightforward. For other traits, they're much more complex, way more genes involved, way more regions, way more risk that we don't really know what those regions do inside the body. And so making lots of changes to those is much harder, and we don't really know what we're going to get. Whereas the ones of the known genes, well, we kind of know what we're going to get. So that's the difference between the two, mate. Like if the productivity, there's just so many genes that create variation, whereas horn pole, quite simple trait that it controls variation with just a few regions. And if we change those, we change things.
Maybe we can nail that calprotectin gene, Sam, through gene editing.
Well, they're the ones that we know a lot about, that people have built careers off for 40 years looking at. They're the ones that are more candidates for gene editing. Ones where you have to just change things for fun and see what happens, well, that's a bit risky.
Myostatin, do we want some more double-muscled cattle? We can change the myostatin gene.
We were just talking about Belgian Blues at a job today. I'm sure we could go again.
Yeah, you could if you really wanted them.
We'll move on to the last question, and my favourite question, and bring the knives out. So the question is, which one of you has the most important job in the red meat industry, the meat scientist or the geneticist?
Oh, the answer's easy. The answer's pretty simple there, Jack. Remembering who puts all the money into the system, and that's the consumers. So, there's you need the meat scientists to make sure we etch out every dollar out of those consumers, and then we can pass it back down the chain to the geneticists and the breeders and the processors.
I'm not sure I agree, I guess. I'd probably say
I was hoping you'd say that, Sam. I was a bit worried if you said something different.
Where does everything start? From the building block of life, there would be nothing without genetics. So I think we can come back to that. We really know where it all starts. And I don't really even have to answer the question.
The old chicken, the egg story, eh?
Yeah, that's exactly right.
Well, guys, it's come to the end of the episode, and we do have those burning questions coming for you. So I think we'll start with Pete. Your burning question today, Pete, is how can we use MSA grading to find more value within the supply chain?
Oh, Sam, good question. Whoever fired that one in, and whether that was you guys or not. I guess we haven't had a great deal of usage of MSA data back into the genetic space across breed plans. So if we go at the genetic angle, first of all, we have done a pretty poor job of bringing phenotypes from carcass grading back into breed plans. So I think a bit of the work we've been doing on technologies. The more accurate the measures, the better we can get those phenotypes. And someone like Darren Hamlin's even created their own technology to put phenotypes into their own genetic analysis in the Wagyu space. So as we see the rollout of technologies across industry, look, hopefully we can find lines of cattle from size that are pretty well unknown that maybe rise to the top, or basically putting more phenotypes against the growing number of genotypes that are getting put in our databases. So that's the first thing. On the other hand, in terms of how can we get more value out of MSA, I truly still believe we're at the very early stages of how we use MSA. So a little bit like switching on Excel, some people can add a few cells up and multiply a few things and maybe write a macro, but very few people use it for analysis and a whole heap of the other suite of things that it can do. And I think we're at that early phase in terms of MSA. So we add a few cells together, we segregate carcasses maybe 1 or 2 or 3 ways, and that's about it. So I think we are still leaving a lot of money on the table. The other area I think is pretty huge coming at us in the future, where we can eke value out of it as well, is around future, like meal solutions. So at the moment we look at older animals, cast for age animals, as trim or as low quality meat, but in reality they've got a lot of omega-3s, a lot of iron and zinc, and a lot of they're very nutrient dense, but we cash them out as trim. So what can we do to them? So combining kind of meat science with food science to make meal solutions out of that whole suite of animals that we look at, like cast for age or high ossification type animals. So I think we're still leaving a lot of value on the table and through MSA. So we've got some miles to go yet.
Yeah, well, hopefully that might increase the cow price at the moment. She's pretty low, but if we can get that coming through, it'll definitely come through.
Yeah, sure. Look, and cow price is probably a advent of supply that's around. We've seen that being pretty high over the last couple of years, but we're still looking at those. We're still really looking at those cows as cast for age or trim animals, and so we're not seeking all the value out of them that we can. And as soon as we change that dialogue, that some will still go to trim, but others will go into these meal solutions. So if you go to the supermarket in the UK, there's 20% of the meat shelf is fresh, and then the other is all ready to eat, ready to cook, ready to reheat type meals. And so pre-made stuff, and there's value in it. We add it with, you put it with a $3 a kilo potato, and you're charging $12 a kilo for that potato. So there's value adding, and we're getting value into the meat through the things we put with it.
Yeah, and no one can afford to eat that sirloin steak every single night too. There's a lot of meat there that we obviously use day-to-day basis in a household that isn't the really high quality stuff. So like you said, getting that out of there and making sure we're using it all across the board for the right animals.
Yeah, correct. There's only so many loin cuts, and then there's all the other non-loin cuts that are perfect for roasting or stir frying or slow cooking. And some of those cook methods really neutralize the effect in those older animals.
Sam, you're not going to get away with it either. You've got a burning question coming at you as well. So your burning question, Sam, is where do you draw the line in the sand between proven and non-proven bulls in relation to risk versus reward?
Okay, well, a tricky one. Thanks, Sam. Thank you very much. I'm not sure who had that question, but I think line in the sand is probably a bit of a trick in a sense for genetic evaluation and breeding programs. Maybe I'm a fence sitter. I think there's horses for courses in a sense that there's sometimes when you'll be thinking of using proven sires and other times when you'll be thinking of non-proven sires. And maybe if we explore that a little, when could we maybe have a little more risk in a breeding program around a non-proven sire, and when would we really want to make sure that what we see is what we're going to get? So let's think about it in tiers of a breeding program. We have the nucleus tier, which are the people breeding bulls, and really the breeders that are breeding sires of sires of sires, so bulls of bulls of bulls over generations. Now, in that part of the breeding program, it actually doesn't matter too much whether it's a proven sire or a non-proven sire. What matters is actually the genetic performance of the animal, so that they're actually high breeding value animals, high genetic merit animals. And we shouldn't really be looking at what is the accuracy of these sires versus those sires. We should be looking at the ones that have the best breeding values or fit the objective the best. When we start to think in lower tiers of a breeding program, say we're breeding bulls and big volumes of bulls to be used in the commercial tier, well, then we can start to think, really, we want to make sure what we see is what we get. So we start to be a little more concerned about accuracy, in a sense, that if we want to make sure that we have a good even line of bulls, and even worse, a good even line of steers that we're producing, or a good even line of heifers, we'd be leaning more and more towards that higher accuracy size, where we actually care what we're actually getting. So it seems a bit opposite to what you would actually think. In the main nucleus of a breeding program, we can absorb the differences in accuracy because you use a number of sires to select sires of sires, and it's really the genetic merit we should be looking at. Whereas further down, where you want to actually manage the risk a little bit more, whether it's in that multiplication tier of producing more and more bulls or producing a final commercial product, we really want to make sure we manage that risk a little bit differently.
And do you think that also comes back to the herd, like you said, it's coming back to that herd that it's in? When you're in a commercial herd, there's genetics coming from everywhere. Most stud programs are following a certain line of genetics. Does that come through, I guess, in that, as you're saying, you're trying to, I guess, maximize a sire, and because you've already got a very strong genetic base of a certain way, you know the genetics are there, and you're taking that risk with a new upcoming sire.
Yeah, and if you think about it, if you're in the nucleus, you're at the top of a triangle, top of the pyramid. No one's really better than you. If you think of the nucleus as the best breeders, they might be a few cows from one stud and a few cows from another. They're right at the top, and it's really hard to find a proven breeder that's even better than them. So you have to take some risk with the young sires coming through. The way you can manage risk with young sires is, instead of just selecting one sire, you actually select a group of sires, because group selection principles allow us to reduce risk. Because if we have a lowly accurate bull, but you have 10 of them and they're all high genetic merit, you can be confident that the offspring on average will be that high genetic merit. So you use more bulls than you do using fewer bulls. If you're going to use only a few bulls, then accuracy matters in terms of risk.
Well, that brings us to an end of our episode with our burning questions there, guys. Really, really great to have both you and Sam on Pete, and thank you both for joining us. Jack, it's been great having you as a co-host again. Thanks for jumping on. We've obviously got a lot going on at the moment, but we appreciate all of you guys jumping on the Breeding Exchange podcast. Thanks, guys.
It's been a pleasure. Thanks, boys.
Yeah, thanks very much, Sam and Jack. Thanks for having me.